Alright, hey guys. Today I wanted to talk a little bit about barrels. And what motivated this video was, I guess, my second air rifle, via Heath and Bull Boss. And I was real excited about it, and then, I just had a hard time getting it to perform the way I'd seen some other people get theirs to perform on YouTube. I just had a hard time getting it past 50 yards. It seemed like I could hold an inch and a quarter group at 50 yards on a good day. And then, I'd try and stretch it out to 75, and sometimes I'd get a decent group, sometimes I'd get a crazy group. And it just got worse as I got out farther. Shooting 100 yards was never, I struggled hard. And that led me to doing all kinds of modifications and upgrades, and now it is what you see here in front of you today. Removed the shroud and just went with a Donnie FL right on the end of it here. Keep it quiet. Installed, I don't know if you guys can see the sticker, but I installed a humor regulator in here. Right now the regulator isn't currently in there. It is sitting right here because I was doing some testing with slugs and I wanted to see the difference in power potential regulated versus unregulated. And in any event, just one reason I do really like the humor regulators, I'll throw that in there real quick, is that you can go from regulated to unregulated and back again without any kind of inconvenience or hiccups. Anyway, back to barrels and how to maybe touch them up, get them to perform a little bit better, and how to know if you have just a lemon barrel, like if there's really just no hope for it, and kind of how to find this out. So some of the processes we're going to be talking about today are going to be slugging. Another process that we're going to be talking about is lead lapping. And another thing we're going to talk about is crowning, the crown of the barrel. So all those things are real important to consistency and accuracy. The crown is this end, like literally the end that's cut into the rifling, and is where the final seal will break as the projectile exits your muzzle. So having this done is critical. Like, that needs to be very well done. The other thing is they have different pitches and different angles for different desired effects. Typically, for target or accuracy, you want the gas to disperse away from the projectile as quickly as possible. So the wider the chamfer or bevel cut on your crown, the better. Like, typically target crowns are like 11 degrees. Hunting crowns and other types of crowns that are made from, maybe if you're walking through the woods and you have potential of banging the end of your barrel, they might be cut a little bit different in order to protect the inside of the crown. So anyway, that's a little bit on that. So briefly, I'll just talk about some of the things I did to this. As you can see, one of the spacers is slid forward right here. I just installed these not too long ago, just to finish this and keep it the way it is. I took this barrel to a gunsmith, had the crown redone, and also had it Cerakoted because the polish that was on, or the finish that was on here, was pretty lackluster and left something to be desired. So let's see if I can get this thing out of here. That's some of the work I've had done to the barrel. I was hoping that would initially fix the accuracy issues that I was experiencing, which I kind of touched on in the other video that I just recently did about scope cams and how they're useful. Because without the scope cam, I probably would have never known that it was as bad as it was. And I'll try and get some video footage up in the scope cam video part 2, where we show some of the results and footage from different scope cams. So that'll be in the scope cam part 2. We'll shoot this rifle. We'll shoot a couple of other rifles, or air rifles, and compare them stable versus unstable, how unstable is acceptable, and that kind of stuff. There's a lot to cover in that field as well. So anyway, we got the barrel out. We'll go ahead and set this thing down. So one of the things that I did after I got the crown redone, and I'll put a snapshot in there because I don't think you guys will be able to see that all that well because this camera sucks for that. But the crown was redone, and this is an 11-degree target crown, slightly inset to get the rifling all cut even. That did improve the accuracy of this rifle by about 20%, but it still did not stabilize the slugs or the pellets, either or. It's the same issue very well. It helped, but it didn't fix the issue. What I discovered was the issue was actually through a process called lead lapping. And this is the exact lap that I used on this barrel. And I'll talk a little bit about the process of this and how lead lapping, what the idea is behind this, is that essentially you're going to cast a lead slug of your barrel, a rather large lead slug, as you can see. You're not going to fire this through your barrel. You're going to connect this, as you can see, to a cleaning rod by using the cleaning rod to act as a dam inside your barrel. Essentially the idea is that you'll stand your barrel up, have a blockage, in this case a brass cleaning brush. This is a 177 brass cleaning brush, so that I could make strokes in both directions without the bristles binding and catching in one direction or the other, making my work much harder. So I used an undersized brush, and these bristles, when they were brand new, just barely touched the inside of the barrel, just very lightly, and I was able to draw it back and forth with ease. The other thing I will note before you get started on a project like this, if you're going to use any sort of brass brush, is to remove the interior O-ring of your barrel. That's really the only critical thing that's going to get ripped up if you use brass, or any like legitimate gun cleaning equipment. You shouldn't damage the steel of your barrel, but it will chew up your O-rings. So before you're going to start doing your lead lap, remove all the O-rings just to be safe, just because you don't want that grit getting in behind them and potentially causing wear later in the future. So essentially you're going to take your undersized brush, place it in the rod or in your barrel such that, like in my case, I put a piece of tape and marked it at this distance. So I had a cleaning rod all the way through here and marked where that cleaning rod ended here. So I had a reference as to how far it was in to pour my cast. Then I took, I don't have it up here with me, I might do an actual video on how to do this process and do it again. But essentially you'll take your lead and pour it into the end of your barrel, and you'll want to heat prime both your brass brush and your barrel. And when I say heat prime, you don't need to get it like molten red hot. Like, it doesn't need to be able to melt lead itself. It just needs to be not cold, so it doesn't make the lead solidify very, very quickly. You want the lead to be able to flow and create a nice uniform, consistent shape. And the idea behind that is taking a perfect cast to the inside of your barrel. When you go to polish it, you're going to be polishing all the surfaces of your barrel evenly and uniformly without favoring any spots. So everything gets the same amount of attention, which is really the best way to do it. That's how any high precision custom barrel, bull barrel, match grade barrel that you'll get in the firearms world, typically that's done at the factory if you get a like a match grade rifle barrel. So this is a tried and true method of polishing the interior of barrels. They might not use the same brush, but this is also not going to damage your barrel. It's softer than the steel used, and you should not have any issues. All the metals on a cleaning head are softer than the steel, so you shouldn't have any issues of damaging your steel. So after this is cast, I'll just finish explaining this real quick. You'll want to slide it to the end of your bore Oh wow, I actually got that lined up right off the bat. Okay. So you'll want to line that up to the end of your bore and then coat it in like something equivalent to this, JB bore compound. This is a not embedding bore cleaning compound. I forget the grit on that. But essentially you'll want to coat this and you'll want to cut grooves in it this way to hold your lapping compound, and as well as put that in your barrel. And then you'll start to run this back and forth slowly and evenly. Typically you'll want to have a swivel handle rod for this so that the lead slug can rotate along the rifling channels real easily without resistance. This will help polish the actual sides of the landing groove on a typical rifle style barrel. You know, this case I think there was 12 lands, maybe 13, I can't remember. Anyway, so that's kind of the process of lead lapping a barrel. I've heard of people covering pellets in bore paste and firing them or pushing them through, and I guess you could do this if you wanted to do that hundreds of times. And I don't like the idea of necessarily firing bore paste, because that's pushing that stuff through very rapidly, and you could get a friction buildup that could, I don't want to speculate too much, but there could be potential adverse effects from firing bore paste through your rifle, aside from getting bore paste in all kinds of, you know, the working components, O-rings, and your probe, and possibly transfer port, and all kinds of other stuff that could just make a mess and cause potential issues down the road. So I would recommend doing it either by hand if you're going to use a pellet, or maybe consider doing a lead lap. There's some other videos by actual gunsmiths on how to do this properly on YouTube. But so that was some of the stuff that I did to try to get this thing to shoot better. All of it helped, none of it fixed the problem. Each step that I did, from recrowning the barrel with a gunsmith who actually turned it, you know, on center on a lathe and did the crown, that made an improvement, but it didn't fix it. And then lapping the barrel made a big improvement, but it also didn't fix it entirely. So now I will show you, you know, slugging a barrel. And slugging can be done in different ways. There's slugging for sizing, in which case, typically in like a firearm, you would take an oversized slug and beat it through with a mallet, typically, you know, a few thousandths over your bore diameter, and you know, whack it through with a smithing mallet and some wooden dowels and get the exact land groove dimensions and all that kind of stuff. Most airgun barrels, the slug isn't actually designed to fit and seal initially airtight. That's why a lot of them have skirts or cup back or dish back or some sort of back design to them, and that's with the intent of helping seal the projectile when the air blast hits it. This stuff that's been around for a long time. So we're going to go ahead and push a slug through here to see what kind of rifling it print. I noticed some things as I was lapping this barrel. Boy, it just gets real easy. It's kind of lumpy going through. And then it gets to choke right there. And there we go. So I'll put a macro video of what this looks like at the end, but it's really interesting. The rifling pattern, not only does it vary in depth, but it varies in length, which is very interesting. It's very consistent. I slugged, I don't know, the same barrel 7 times, and every slug looks identical. So it's not a slug centering issue. It doesn't matter if you put a really long slug, an oversized slug, whatever. It cuts unevenly. The rifling groove depths are not consistent, and you know, I don't believe that you'll ever get accuracy with a barrel that's, you know, not consistent on that type of a level. the other thing that I noticed is as I was drawing my lap back and forth, as I mentioned earlier, I had it marked on my rod so I could tell how far in I was and where I was in relationship to the end. And I had this on a wood block standing upright, and I was drawing vertically. And after, it started getting smoother, I started hearing a distinct whack, distinct knock, is what it sounded like, just like that, at the end of the stroke. And I was like, okay, I must just be tapping the wood. That's good. It's going through nice and smooth, nice clean passes, not much resistance. And then I noticed the tape, it was thumping, but there was still about that much tape above the barrel, which means this wasn't all the way in. It was hitting something hard inside the barrel, right about in here. And I was like, well, what on earth could be making that kind of a sound on a lead lap inside something that's supposed to be pretty smooth, relatively anyway? And that got me thinking about how they might have made the barrel and the barrel choke. And if they did it the way I think they did it, there's a high probability for error. It seems like, after looking at this quite a few times, that the bore was actually drilled in 2 diameters, right? So they drilled a smaller drill hole all the way through to start with. That was going to be the final choke size. Then they followed that up with a bigger bit and stopped that bigger drill size somewhere closer towards the muzzle, but not all the way through, and that was going to facilitate the choke, essentially. Having a bigger bore diameter reduced down to a smaller bore diameter at the very end of the muzzle is effectively a choke. And then I'm assuming that they rifled the barrel either by button or hammer forging. I'm not exactly sure, but I can tell that the outside surface of this is very uneven. Anyway, there is a distinct ledge that you will see in the macro video of the pellet getting really just brutally smashed on one side, and from pushing it through, you really get the sensation and feeling of it, as well as in the lead lap itself, there was a visible mark of a ring, distinct on one side and one side only. And so that's some methods that will help you identify accuracy problems if you're experiencing them and you just don't seem to be able to get rid of them. It might not be your tuning ability, it might not be your ammo. You might want to take a look at your barrel. And there's some things that just aren't fixable, unfortunately. So, this barrel, as far as I'm concerned, is trash, which kind of makes my Bull Boss useless, which is unfortunate. But, that's just something I wanted to share with people, and to maybe you can use this type of method as well for sizing, to figure out what's going to be the most ammo or most appropriate size for your ammo. One of the other things too is there's a lot of inconsistencies in bore diameters due to the fact that Diabolo pellets have their flared skirt and very thin skirt design allows them to flare and seal and seat in a variety of different barrel diameters and perform rather well. It's a pretty forgiving projectile in that regards compared to a modern ogive slug shape that is really requires much more precise barrel fit in order to accomplish, or in order to get the right results. So that's something that I think maybe some of the airgun industry is going to have to catch up on and address if they want to start delving into different ammo types, or even just shooting their own, the standard ammo better, because this thing didn't shoot Kings that great, or King Heavies, or Barracudas, or really anything. It spiraled the crap out pretty much everything, and it just got worse beyond 50 yards. Up into 50 yards, it was definitely usable for hunting. You weren't going to win any target competitions, but you could definitely dispatch squirrels and birds and what have you. And it's got plenty of power to do much bigger game than that as well. But from a long range perspective, there's really not a lot of potential for this particular rifle. So I know other people have had really good results with their Hatsons. So I know that they're capable of, some of their barrels come out really well. This one did not. And so this is maybe a way for you to figure out what your barrel's like. And this isn't just about Hatson. This is just about barrels in general. This is about, how you can check your barrels. Stupid table. Everything's falling over on me. This just happened to be an example of something that wasn't done right. And I can only assume that there's going to be other people out there that are going to have a similar experience with some air rifle or another, and it can be really frustrating. And not knowing how to approach the situation can be even more frustrating, and that thing's really starting to irritate me. But so with that, I'm going to cut the video short. If you guys want to see some more on this, leave some stuff in the comments, and I'll try to actually make a lead cast lap and put that on video and show you guys. So anyway, that was my little barrel segment. And alright, hey guys, so hopefully we'll get this where you guys can see it well. This is the slug that we just pushed through the Hatson barrel. Get this at an angle where glare is not ridiculous. Alright. Get this focused a little better. Alright. So, as you can see, I drew a ring, or scribed a ring, around the slug here. What this is you'll see right there, that is the shortest rifling land. That land is ends at this line. So as I spin this, notice that, oh, stupid camera, come on, locking me out. As I spin this, notice how much higher these lands are than this land. Hopefully you guys can see that. That's a huge difference. These lands that are longer are also substantially deeper than the lands that are shorter. This has to do with that choke that I was talking about, squeezing unevenly from one side to the other. So this is evidence of this right here, showing that this side didn't get nearly the pressure applied to it that this side did. The rifling grooves are cut much, much deeper, much more pronounced, and this is going to have the effect of unbalancing your projectile as it's flying. So anyway, I just wanted to show you guys that, and maybe what to look for when you're doing this with your own air rifles. Alright.